So this is the second lesson on the extra stuff for higher level maths in the number strand. The first thing I just want to mention is the concept of present value. This is very quick. The idea is that so I'll say PV is the present value and FV is the future value, so the value at a later date. So if you have a certain amount of money now and you're making I% interest for n years, then you have FV, future value, amount of money at the end. So I is equal to percentage interest. So that would be a number, 1% would be 0.01. So 1% is equal to 0.01. Since otherwise I'd kind of go, if I'm making 5% and I say I is percentage, then I would equal 5. No, if you mean 5%, I is equal to 0.05. And n is how many years. So if you were to get 5% for 10 years, then n would equal 10. So n is equal to years. So all you have to do is flip this around. The present value is equal to the future value divided by 1 plus I to the n. And you can plug in the various numbers, but you just put them into this formula and you're done. As I said, it's pretty quick. So next we're just going to look at this idea known as induction. It's a powerful tool used for proving things. So what you do is, say you want to prove that 2n is greater than n, and n is greater than 0. So where n is greater than 0. Because obviously if n was minus 1, well then minus 2 is not greater than minus 1. So what you do here is you first show that true for n is equal to 1. So in this case, if n is equal to 1, 2 is greater than 1. So here n is equal to 1 means 2 is greater than 1. So check that. So check 2 is greater than 1. And it is. So then what you do is you assume statement true show that true for n plus 1. So if n is equal to n plus 1, we'd have 2n plus 1 is greater than n plus 1. So I have to now show that this is true, and I'm allowed to assume that 2n is greater than n. So what can I do here? Well, that means 2n plus 2 is greater than n plus 1. I'll take 1 away from both sides. So 2n plus 1 is greater than n. Now I'm allowed to assume that 2n is greater than n. So if 2n is greater than n, then adding 1 to the side which was already greater is not going to change things. If anything, it's going to make the left hand side even bigger. So if 2n is greater than n, then 2n plus 1 is greater than n, so true. The idea being that what we do is we show true for 1. So show true for 1, and then we've proven that it's also then true for 2n plus 1. So basically we go, well, if it's true for 1, then it's also true. That implies it's true for 2. If it's true for 2, that implies it's true for 3, and so on. And you get to that it's actually true for all n. That's the basic process that we go through. We look at various particular things and proving them by induction. So like 2n greater than n was just one I picked off the top of my head. We'll go into that in greater detail in the video that you can just click on the button and you'll be taken there. So in that we go through, or in that video they go through in detail the various things that we need to know about induction.